Hello students, today we are going to start with a new chapter, polymers. We cannot think of a world without polymers. In our day-to-day activities, we are using polymer. Even our body, many parts of our body, think about this, the protein present in the skin, the protein present in the muscles, the hair fibers, they are all proteins. Even the DNA, RNA are the nucleic polymers. They are the proteins of the nucleic polymers. So you should know that our body, like the strings present in our cloth, these are also a polymer. Even if you think about our day-to-day activities, we are using the polythene bags, we are using the PVC pipes, these are all polymers. So we cannot just define the word polymer because it has been interlinked or intermingled with our day-to-day activities. So today we are going to stick to polymers. If I want to tell you the definition of polymer, please take a note of it. A polymer is a high molecular mass compound. A polymer is a high molecular mass compound around 10 to the power 3 to 10 to the power 7 AMU. I repeat, 10 to the power 3 to 10 to the power 7 AMU obtained by joining a number of repeating structural units, what we call it as these monomers. Many such kind of repeating structures are called monomers, and when we join it together, we get a polymer. Remember, it should be in a regular fashion. I repeat once more, as polymers are high molecular mass of around 10 to the power 3 to 10 to the power 7 AMU obtained by joining repeated structural units called monomers in a regular fashion. If I want to show you if I call this as a monomer, if these monomers are being joined together one after another, then it becomes a polymer. So how many monomers are being needed? 1, 2, 3, 4, 5, 6, 7. So 7 monomers makes a polymer over here. But be sure that the total molecular weight should be within 10 to the power 3 to 10 to the power 7 AMU. So when they are being added together, they are called as a polymer. So now the site, for example, these monomers are being added with the other monomers but two reactive sites. This is what we call it as the functionality. So functionality means it is the total number of reacting sites present within the monomer molecule. So this, if I take this as the monomer molecule, this is the reactive site, this is the reactive site. So the two reactive sites are the functionality. So when questions would come, what is functionality? You have to see it depends upon the number of the reactive sites. The number of reactive sites present in the monomeric units is what we call as a functionality. You can see here that I have added 7 to 8 monomers to make a polymer. This is what we call as the degree of polymerization. So degree of polymerization is the number of monomer units present in a given polymer molecule. So in a given polymer molecule, how many monomers are being added to make one molecule of a polymer? This is what we call as the degree of polymerization. Now we are going to consider about the homopolymer and copolymer. A homopolymer is a polymer obtained by identical monomer units, while copolymer is a polymer obtained by two different monomer units. I will give you some example. Say in this ethene, CH2 double bond CH2, CH2 double bond CH2, these are all ethene, CH2 double bond CH2. What happens? This is the sigma bond and this is the pi bond. The sigma bond and the pi bond, the sigma bond and the pi bond. Pi bond being a weak bond, so under certain temperature and pressure with the effect of the catalyst, this bond breaks up, this bond breaks up and they join hands with each other. So these are the monomers and many such kind of monomers. So n times these monomers, the n times they repeat and they become a polymer. This is what we call as the homopolymer. So homopolymer would contain the identical monomers, same type of monomers, but when it will be of different type monomers, we call it as copolymer. For example, if we think about nylon 6,6, just student, if you have hexamethylene diamine, this is hexamethylene diamine, hexa, hexamethylene, hexamethylene diamine, amine. And if I add here COOH, this is adipic acid. Adipic acid, what happens is under certain temperature and pressure, these molecules of water is evolved, and you can see here OH with H, similarly this H with other OH, and this goes on and it forms NHCH2 whole 6, NHO, C double bond O, CH2 whole 4, C double bond O, and so on. This is what we call nylon 6,6. So nylon 6,6 is a copolymer. Why? Because there are two different types of monomers which have taken place together to form a unit. So it is called as a copolymer units. So two different types of monomers are being used here. Here we are going to classify the polymers under four heads: on origin, on structure, on polymerization, and on molecular forces. So first one on origin, second on structure, the third on polymerization, and the fourth based on the molecular force. So if we think about on origin, we can classify under three heads: natural polymers, semi-synthetic polymers, and synthetic polymers. Natural polymers, what we get it from the animal or the plant origin. Say starch, cellulose, proteins present in our body, DNA, RNA, the nucleic acids, natural rubber, they belong to the natural polymers. If I go to the synthetic polymers, what we are making out means man-made. Synthetic here means man-made. We do it. How we do it? Here we see we are getting the PVC pipes. This is also a PVC pipe, PVC boards, Teflon. Even this board is a PVC one. Teflon, you have seen the non-stick cookwares. The underneath the electric iron, you get the Teflon coating. Nylon, bakelite, these are all man-made. So this is synthetic polymer. And when we join the natural and the synthetic polymers together, we get the semi-synthetic polymers, which includes the cellulose diacetate. You might have seen while you have the aquaguards in your home, there is a membrane which helps to undergo osmosis or reverse osmosis. There we use cellulose diacetate. In making bombs, in the many chemical warfares, we are using cellulose nitrate. So it is used as an explosive. Vulcanized rubber, we are getting the natural rubber, that is the natural one, and the synthetic part is sulfur. When we punch sulfur with the natural rubber, we are getting vulcanized rubber, and it is used in making the tires of the vehicles and so on, which makes it very hard. So this is how we divide into, on origin basis, natural polymers, semi-synthetic polymers, and synthetic polymers. Examples are being written. I hope you can just see it very nicely. Students, I would ask you to learn the examples. Once you learn the examples, your work will be almost 80% covered. On basis of the structure, if it happens that the polymer is a single strand, here we call this as a linear polymer. When that single strand is having different branches, It is called as a branch chain polymer, and when these many such kind of branches are interwoven by other branches, so you will have a cross link. So cross link, you cannot just, if I take a linear polymer, I can just go on, I can just keep on putting one after another layer. I can make into high density, but in cross link, this strands does not allow it to come over, and so they are of low density. So branched and linear polymers, they are usually of high density, but the cross link, you cannot just put one after another layer to it, you cannot fold it, and so it is of low density. Linear polymers includes the PVC pipes, the HDP, that means high density polythene, nylon and the polyesters. Branch chain polymers will have the low density polymer, and they are of, you can think about the glycogen present in our body is also a branch chain. Amylopectin, that you are getting it from the starch. The starch usually contains this amylopectin, and this amylopectin is a branch chain. And in the cross-linked polymers, we include bakelite. You know, the switchboards, this is a bakelite. The pressure cooker handles, this is a bakelite. Melamine, you know that non-stick cookwares or micro-oven cookwares are made up of the melamine formaldehyde resins. Urea formaldehyde resins are also being made. They are heat resistant. So they are cross-linked, but remember, all these cross-linked polymers are very low, having very low density. If we go on basis of the polymerization, that we divide into two categories. One is addition polymers and the other is condensation polymers. If I have already given you that is example CH2 double bond CH2. If this monomer is being repeated, it becomes CH2 single bond CH2, and it joins with another more CH2. There is nothing getting subtracted. Everything remains the same. And in addition polymers, you just go on adding the monomers without any loss of the molecules. There is no loss. But in case of the condensation polymers, when you join the molecules, remember, usually there will be a subtraction of water or any other compound, but there will be a loss in the total molecular weight. If I have examples like this, CH2 whole 6 and NH2, this is what we call hexamethylene diamine. And if I think about another such compound like CH2 whole 4 COOH, this is called adipic acid. This is hexamethylene diamine and adipic acid. When I polymerize it, it becomes NHCH2 whole 6 NHCO CH2 whole 4 CO. So you can see there is a loss of water molecule. So when there is a loss of water molecule, is the condensation polymerization. So what happens is, when the two monomers are being brought together to form a polymer, there will be a subtraction of the compound, and the total molecular weight, you can see there will be a loss in weight. Why? Because then the water will be subtracted out. So addition polymerization, there is no subtraction of any water or allied things. But in condensation polymers, when the monomers, they join together, there will be a loss and the compound will get condensed. This is what the name comes here, condensation polymerization, because they do mix up with a loss of a compound, usually that is water. So student, if I see once more on origin, it is natural polymers, semi-synthetic polymers and synthetic polymers. On basis of structure, we can see it is divided into linear polymer, branch chain polymer, cross-linked polymer. On the basis of polymerization, we can have here addition polymers, condensation polymers, And these addition polymers and condensation polymers differ only here that nothing is being subtracted here, and here there is usually a loss in the molecule of water. Our last thing that we should go is on basis of the molecular force. You know, like there are many polymers which have got elasticity. Some, you know, like if I take a pen and try to pull it, it's not having any elasticity. So it's not deforming its shape. But if I take a rubber and I produce a strength there on the either end, it will get elongated. And if I release it, it comes back to the original phase. That is, the elasticity is present in some kind of polymers, and there are no elasticity in some polymers. So on basis of the molecular force, whether they are strong enough or they can be expanded on using a kind of force externally. This is how we divide into elastomers, fibers, thermoplastic and thermosetting plastics. So we divide it into elastomers, fibers, thermoplastic, thermosetting plastics. Examples are being given here: Buna S, Buna N and neoprene. So you can see, student, these are of rubber variety. So elastomers, they include the Buna S, Buna N. You might have seen 1,3-butadiene with styrene. When this Buna S, it means here it is 1,3-butadiene with styrene, and when you use it, this is usually made for compounds where we use for storing oils. Particularly, you have seen many. So student, here you see Buna S, Buna N, neoprene, they are called as elastomers because when you put a force, it gets elongated, and when you are releasing the force, it comes back to the original state. This is what we use for the elastomers. Usually we make the tires, the oil seals. Even you bring the oil in the packets. The packets are usually made up of these elastomers. The next thing is about the fibers. Fibers include, the nylon fiber used for stitching clothes, the fabrics rather, the mosquito nets. These are all nylon 6. Even the parachutes are used by using this nylon 6,6. Terylene, we are using it for weaving these fabrics. Dacron, acrylon. It is a synthetic wool, we can say. You can see nowadays wool is very costly, so we are making a synthetic variety of this wool. That is what we call is the acrylon. Thermoplastics, we go for like polythene, PVC, polystyrene, polyvinyl nitrile and Teflon. So these are thermoplastic. What is the characteristic of this thermoplastic is that when you heat it, it melts and you can mold it into different shapes. For example, if I have a mug, a plastic mug, and if I heat it, it will melt and I can make into some other shape. But if you want to have a plastic chair, and you melt it and you want to deform it into some other shape, that is not possible. Like if I want to have this bakelite, and this bakelite, I want to heat it and make into some other shape, that is not possible. So they are called thermosetting. Once it has been set into plastic, it will not get deformed. Even you can heat for long. It can burn, but it's not going to melt. So thermoplastic includes the polythene, the polyvinyl chloride, polystyrene, polyvinyl nitrile and Teflon. You can see that many people, those who are buying our those plastic materials and all, what they do, they make a choice. They take those plastic material which can be molded. They won't take any such kind of plastic material which cannot be molded. So this is the non-molding path is the thermosetting plastics. You can use bakelite, 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 melamine formaldehyde, formaldehyde, formaldehyde resins. These are the examples. Urea formaldehyde resins is also a very good example. The microwave cookwares. You cannot just get deformed if you heat for around 3000 degrees centigrade. It may catch fire, but it will not get burned. This is what that melamine formaldehyde resins are used for. Once it has been set for making plastic, you cannot get it deformed even after repeated heating. So hopefully you have understood about the classification of polymers. I will ask you to take a short a screenshot for it so that it will be helpful for you in the long run.